In this video, we're going to discuss about inverse systems. So what is an inverse system? Let us say I have a system x of n. I have a signal x of n, and I have a system which is characterized by its impulse response h1 of n, and the output I get is y of n. Now, if I feed this output y of n into another system h2 of n such that the output z of n is equal to x of n, then I can say that h2n is the inverse of h1n. So the system h2 is the inverse of system h1 if my this output is same as this output. So basically, if zn and xn are same, then the overall effect of this system is unity. I can write it like this. My Zn is x convolved with h1 convolved with h2 of n, and this is equal to x of n. Therefore, I can say h1n convolved with h2n is equal to a unit impulse, which means it is unity. Okay, so can we always find an inverse? The question is it possible to find an H2 always such that the overall effect is unity? No, it is not always possible, because if H1 loses some information of X, then there is no way I can recover that information, right? This is simple information principle that if you're losing information here, how can you recover the information here? So that is why, an extreme example will be if h1n is always 0, means yn will always be 0, then I can never reconstruct X using any system. Now let us look at one example of how to find the inverse systems. For example, if my h1 is an accumulator, then this means my h1 is simply a unit step function. If you remember what's an accumulator basically is my yn is equal to summation of xk, k goes from minus infinity to n. This is my accumulator system, and if you remember from previous video, we have another representation, yn is equal to y of n minus 1 plus x of n. There's another representation using linear constant coefficient difference equation. Now I want to, so my h1 is an accumulator, and my h2 is what I have to find. So what should be my h2? If this is an accumulator, what should be my h2 such that the overall effect is unity? So that if I feed an xn here, in the output also I get an xn. Right? This is the question. So I know from my theory h1 is the unit step function for an accumulator. Now I have to find an h2 such that transformation of a un. So if this is delta n, this will be u of n. Right? If this is delta, then this will be u of n. I have to find that an h2 such that transformation of u is delta. So in this way, we'll be using some known results to be able to get to a form of h2. So what is that known result? I know that un minus 1 is delta n. If you remember the mathematical jugglery which we did in the last week. So we can use this result and put it here, that transformation of un, which is equal to delta n. So this means that this transformation is basically, it becomes this thing, right? This means my yn is simply xn minus 1. This is your yn. Or if you want to use the notation of Zn, then this will be okay, Zn. then this is Zn equal to Yn minus. So this is Yn, this is Yn minus 1. Right? This is one way to derive the inverse solution. But can we do it in a more principled way? Okay, let's look into that. To find the inverse of an accumulator. Another way, let's observe, let's start from the constant coefficient difference equation LCCD representation. So in this representation, I know my y of n from the accumulator, it is equal to x of n plus y of n minus 1, right? This is already what I have seen. And I know that my h1 of n is equal to u of n. This is already known to me. Now, let's try to see the output of the second system. The output of second system is z of n, which is equal to, in general, h2 of n convolved with the input, which is y of n in this case. And this is equal to, okay, I don't know what is h2 of n, but I know what is y of n. Convolved with yn is xn plus y n minus 1. Right? So this becomes equal to h2n convolved with x of n. Okay, so my requirement is that my z of n should be equal to x of n, right? So this should be equal to x of n. So that the system is unity, the inverse system of h1. So now I can say this is h2 of n convolved with x of n plus h2 of n convolved with y of n minus 1. Okay, now how do I proceed further? I'm in a trouble. Why? Because I do not know what is convolution of something with something n minus 1. Let me show you. Okay, if my xn convolved with hn is y of n in general, then what is xn convolved with h of n minus 1? Okay, I don't know. So let's try to derive this. Let's consider my xn is something like this, right? 0, 1. This is my x of n. And my h of n is something like this, which is 0, 1, n. Now, this is my h of n. And the convolution will be, the way to find convolution is you reverse h of n, right? You make it like this, like this. So this becomes h of minus n. And then you shift it further. And then that's how you find convolution, right? But now in the other case, now you have x of n is the same, 0, 1. But my h of n is h of n minus 1. So my h dash n is equal to h of n minus 1, which means a delayed version. So everything will be moved here. This will be 1, 2 instead of 0. So 0 will be nothing. This is my h dash n. And their convolution will be, okay, I reverse the thing. If I reverse, this comes to minus 1, minus 2. This is h dash of minus n, right? And what you find now is that these two are exactly same, but if I have to just move one step further, which means my y dash of n will be equal to y of n minus 1. right? So this is the thing. My xn convolved with hn minus 1 will be equal to y of n minus 1. Since convolution is it commutes, so and with symmetry, I can say this is also same, y of n minus 1. Basically, whether you turn hn and which gets shifted, or you just shift xn and don't shift hn, the result is the same. That's why this is simply yn minus 1. This is now a little more tricky, but if you understand this argument, then this is also easy to understand. So now in this case, you have x dash n, which is, it starts from 1, 2, and then you have h dash n, which again starts from 1, 2. Right? Now if you turn this thing, you have to go 2 steps further to be able to reach that same configuration. So this means that your y dash of n will be equal to y of n minus 2. It has to shift 2 steps. So this is equal to y of n minus 2. So you can derive a general form. The general form is x of n minus nx convolved with h of n minus nh. This is equal to y of n minus nx minus nh. So this is your general form. Okay, so using this formulation, now let's go back to our inverse systems problem. Now I can say this thing. I know h2 convolved with yn is zn, so h2 convolved with yn minus 1 will be z of n minus 1. Right? And you know that your z of n is xn for the system to be an inverse system, for h2 to be an inverse of h1. This means my z of n minus 1 will be equal to x of n minus 1. Right? Substitute it here. So what I get is x of n minus x of n minus 1 is equal to h2 of n convolved with x of n. Okay. Now you can directly compare the forms that, okay, h2n is unknown and xn is known. So can I write it like this? This can be written as delta n minus delta n minus 1 convolved with x of n. Right? This is simply a delay system. This is equal to h2 of n convolved with x of n. Now you can clearly see that you can take h2 of n is equal to delta n minus delta n minus 1. This is your answer. So now we have used a more principled way to derive the same result. If you look at the previous result, it was also h2 was equal to, so this is h2 is delta n minus 1, and here also h2 is in this form. So this is how you derive inverse systems, and this is some new result in convolution which we have seen. Thank you very much.